This method can help answer key questions in the nuclear mechanics field. For example, what is the force required to deform the nucleus in a cell? What are the contributions of cellular and nuclear components to nuclear resistance to deformation? Or does nuclear coupling with cellular structures vary with cell type?
The main advantage of this technique is that it allows us to apply pulling force to deform the integrating nuclear cytoskeleton in a living adherent cell.
Though this method has been used to provide insight into the nuclear mechanical properties in NIH3T3 cells, it can also be applied to any adherent cell type, such as probing the nuclear mechanical properties in Hutchinson-Gilford progeria cells.
To begin this procedure, coat a 35 mm glass bottom dish with 5 micrograms per milliliter of fibronectin. Then, culture the NIH3T3 fibroblast cells in DMEM supplemented with 10% donor bovine serum and 1% penicillin streptomycin on the coated dish at 37 degrees Celsius until desired confluency. Immediately prior to the experiment, wash the cells twice with PBS, followed by a single wash with complete growth medium. Afterward, add 3 milliliters of complete growth medium to a glass bottom dish. In this procedure, turn on the microinjector. Using an immersion oil dropper, apply a drop of immersion oil on the objective lens. Then, clamp the dish tightly to the dish holder and load the dish holder onto the stage.
Please note that the cells should be maintained at 37 degrees Celsius and 5% carbon dioxide throughout the experiment.
Next, adjust the height of the objective to bring the cells into focus.